Good morning. The subject is control system and the unit is first unit and the name of the unit is modeling of linear time linear system. In short, you will be seeing it as LTIV. So first initially we have to know the introduction of the control system. So it is a first we have to know what the system is and how we are controlling the system. That's the thing we are going to study in the subject control system. Okay. So first of what do you know about system? Okay. The system is a device. Is any form of physical device. Where they have given some input and we will be the system will be doing some process and finally we will be getting out the output. So then the computer will be saying the computer is as a system. So in our electrical appliances we will be saying it in a particular physical devices as a input. Okay. So if we are giving an input to a particular physical device and we are getting an output, that is said to be system. Okay. So there are two things are in there in the system itself. One is now as I said before, here it is input, right? See, so it is a I'm considering this block as a system. As I said, we are giving an input to the system and we will be getting out the output. And this is, if you see this, it is giving an input to the system and we are getting some output. There is no loop over here since it is open. Okay. Input, getting of output. So this system is said to be open loop system. This system is said to be open loop. Whatever the input we will be giving, what is the system present in there? Based on its function, we will be getting the output. There is no return back of there. Okay, so this system is said to be open loop system. The second thing is if we are giving an input to a particular system and we are getting an output over here and from the output we are taking again to a from the output we are taking a feedback system again we are giving to the input either by using a feedback controller or not using a feedback controller. If you are saying I am using a feedback controller means I will be putting a block here and I will mentioning it as controllers or as feedback system or else I will be mentioning it as feedback system. Okay. If even though if it is not here it's also if this system is closed, this is said to be closed loop system. Okay. If there is a block of feedback, then it is said to be feedback closed loop system. Okay. If there is not, just it is a closed loop system. So these are the two types of systems that is the concept of control system. One is open loop system and other one is the closed loop system. So now we know what is a system and what is control system is doing. We have to know that. First, I am going to I am giving an input. I am going to name it as R. Okay. And what I am going to take the output as C. Okay. So now I am giving an input. Whatever we will be doing it with reference to what? With respect to time. So I am going to mention it as R of T. So the output also I will be getting with respect to time. So I am mentioning it as C of T. So if R of T is the input which is being given to the system, I will be getting the output C of T. Okay. So now I am saying system. Okay. So for any system, we need to control the system. Okay. It's a physical system. I am not getting my required output. There is some disturbances in it or some sort of things are present in it. So I need to control a system by using an external controller like this. By using I am going to just taking a feedback from the output side and again injecting into the input side. So if I want this operations, okay. So what I have to do, I have to calculate it first. Yeah. So I have to calculate what is the output comes here, okay, and what is the input I have given. For example, if I am teaching for you, okay, so you are listening. So my teaching is the input which I am giving, and your listening your response. Okay, so that is your output. Okay, how come I know how my teacher reaches you? I have to calculate difference. Whether I have to calculate your response to my teaching. So we will be doing what? A mathematical operation. So likewise, that mathematical operation that I am going to, that transfer function. That is named as transfer function. Okay. So transfer function is what? Your response or your level of listening to my level of teaching. So to my level of teaching means what is the terms? There is a ratio. Okay. So transfer function is defined as that we will be taking it as a Laplace transform. Okay. So transfer function is defined as Laplace transform of, okay, Laplace transform of output to the Laplace transform of input. Laplace transform of output to Laplace transform of input. Here I am going to mention a condition. Okay. So Laplace transform of output to Laplace transform of input is what? Transfer function. Under what condition this is applicable means with zero initial condition. With zero initial condition. That is, initially I am going to take, I haven't given any teaching to you and you haven't listened anything. That is the initial condition. Now only I am going to give input. For that input you are going to give response. Okay. So based on that ratio, you will be calculating some mathematical thing that is said to be transfer function. Is an important prediction, important to know questions and all. Okay, so that is transfer function is equal to Laplace transform of anyhow. Any time you want to know that Laplace transform of output divided by Laplace transform of input with zero initial condition. That's it. Transfer function. Okay, so now what is the Laplace transform means? Why you are applying? You can do it. Your response to my teaching. That's it. Why I am going to Laplace transform? Is that any guessing?
With respect to time.
Not with respect to time. Why we are going to Laplace transform? The system differs, right? Either I can say this being electrical, I can say that my system may be a motor. So motor, what is the input? I am giving a, for motor we will be giving electrical energy, and what will be earning a
Mechanical energy.
rotation. So I will be earning a mechanical energy. So the system varies. For if I am taking example as a motor, the input is electrical energy, the output is mechanical energy. If I am taking other system, that is generator. Okay. So what is my input there?
Mechanical energy.
What is my output there?
Electrical energy.
So system differs on its function. Okay. So in common, I have to calculate for a response output. That is in a response ratio. So I am going to take the Laplace transform as the common. Okay, that for that what we will be saying is as yes domain. We will be saying that as yes domain. Okay, because based on the system, my input and my output varies. For each system, I can't able to do separate calculation. Okay, either my system may be a motor or my system may be any sort of physical device. I have to take a common calculation. So for that purpose, I am going for a yes domain, that is Laplace transform. Okay, and now what do you know about that feedback? I have said feedback control system, right? So if I am joining a feedback block over here, this is a feedback system only. From the output to input, if we give a means that it is feedback. So taking from the output, again we are giving it an input, which is a feedback system. Now here there is a, so as I said, for input I am taking it as R of T, right? And output is C of T. What the system I am going to name it as G. The system I am going to name it as G. If my system is G means, okay, what is my feedback I am going to use as H. Okay, these are the notations we will be using to the transfer function. System is represented as G. We will be saying that as system representation. Okay, so system representation we are going to take it as capital G, and the feedback representation we are going to take it as
Capital
H. Okay, so if R of T is my input, if I am taking Laplace transform to it, I will be changing it in what domain? Yes domain. So my R of T will become capital R of S. And likewise, my system transfer function is G of S. And my output transfer function is
C of S.
C of S. Okay, these are the representations you want to know.
Yes.
Okay, and for feedback, if it is feedback control system, what will be the transfer function of it?
H of
S. Okay, first step we will be doing. We will be converting to respective time. We will be converting into the S domain representations. Okay, and in the feedback control system, there are some characteristics. So based on the applications of the system, can you name any of the characteristics of the feedback control system? What it will do?
It gives the output to input to increase the gain.
To increase the gain. As you said, the G is also what? Gain.
Gain.
Okay, this G stands for system, or else we will be saying it as gain, or else that is capital G. Okay, and as you said, what is it? If we are giving an input, we are getting an output. Okay, so for that purpose, what is the if we are taking a feedback to again to the input means what is happening there? There is a sensitivity. We will be naming it as the exact term is sensitivity. Okay. So that is the sensitivity of the system for what? For any parameter that is being given to the input. Okay. That is the first characteristics. The next is now I have changed some parameter. Okay. So here I have changed some parameter. So my system is sensitive. If I change any parameter, the system functions will respond to that. And accordingly I will be getting the output. Okay, so this mode of operations is we will be saying that steady state operation. Okay, if the error occurs means what it means steady state error. Under steady state condition, if error occurs means what will be doing? Maintaining it as steady state error. So that error we have to reduce it. So in order to reduce the error, again we will be doing the feedback operations again. Okay, this is a cyclic term for feedback control system characteristics. And the other thing is, feedback control system, one more characteristic there. Can you think about it? What may be the other characteristics? We will be saying it as transient response. Okay. So giving an input. So that we will be getting an immediate output. That is, if you are giving an input in terms of parameters or in terms of any source, what will be getting? We will be getting a transient response over inside the output. These are the characteristics that comes under the feedback control system. So the next thing you want to know is one is linear system. I am saying it as modeling of linear time invariant system. Other system is linear time variant system. Okay, so based on time, if it varies means what it is linear time variant. Okay, if based on time doesn't vary means it is time invariant system. Okay, and another thing you want to know is what is linear system and other is non-linear system. So the linear system which means that obeys the superposition principle. What is the superposition principle then? Have you studied superposition theorem? What it is? So whatever the input we are giving, we will be get the output accordingly. For in definition, if you want to say means the linear combination of input is equal to the linear combinations of output. In circuit theory, you have been studied it as the sum of the input side is equal to the algebraic sum of the input is equal to the algebraic sum of the output. This is how you have solved the circuit. Whatever the input, if we take a electrical system, the input may be voltage or current. And if we take a mechanical system, is what will be the input and what will be the output? The mechanical system.
Torque.
Torque is the input or output. Then what is the input then there?
Force.
Okay. So if we are input as force, if we are giving it as, we will be getting an output. So as you said, the input for mechanical system is what? Mechanical system input is
force.
Yeah. So I am giving to a system. Okay. So I am going to mention the components of system. Okay. This is a system. Now we are going to see the second thing, that is the system is mechanical system. So the mechanical system, what are the components? Okay. So what are the components there will be? There is a mass. Okay. There will be a dashboard. Okay, and one more thing there will be the spring. For example, the mass of a system. Okay, we will be naming it as M. Okay, dashboard. Dashboard is just the piston which is present in your mechanical system. Okay, now suppose if it is a mechanical system, what will be there? There is a piston. Okay, so that piston will be naming it as B. That's dashboard. The mass is represented by M. Dashboard will be represented as B. And one more thing that will be present in the mechanical system is spring. Okay, so I am going to mention the spring as K. The spring will be represented as K. Okay, these are the three components that we are that is present in the mechanical systems. Okay, and as I said, here the input is what? Force. And the output will be torque. Here we can take this theta also. Okay, so for mechanical system it will be like this. Okay, and so taking it as x. Okay, the output will be taking it as x. Okay, for f input, what is the output? X output. Okay, so what is the transfer function then?
Laplace
transform of output means what is the Laplace transform of output? X of s. What is the Laplace transform of input?
F of s.
Then what is the formula for transfer function then? Transfer function is Laplace transform of output. What it is? X of s by Laplace transform of input. That is F of s. You have to write the formula first. Transfer function is equal to Laplace transform of output divided by Laplace transform of input with zero initial condition. Okay. After writing that here, according to this, we will be seeing the problem related to this. Okay. So that f of s input, x of s the output, to calculate the transfer function, it is x of s by f of s. Okay. So these are the three components that is being represented. So for this representation, okay. For this representation, you have to know two things. One is how the differential term will be for this. Okay, see, for these things in how will be the differential form and how will be the Laplace transform form. For mass, this block is differential equation form and this is after taking Laplace transform. So for mass, the differential form is its mass. Take M d square x by dt. Okay. And for dashboard. Okay. For dashboard is represented as B. It is dx by dt. Okay. And for spring, it is K. That's it. Okay. K with respect to what? Time t. Okay. So if we take Laplace transform from a second order derivation, what will be the response then? Laplace transform of will be taken as Laplace transform of m d square x by dt square. What will it be? It is dt square. What it will be? It is m. Yes, domain also goes to the second order. That is s square. Okay, mx square. What is here? X of s. This is the Laplace transform of the mass. Okay, and what is the Laplace transform of the dashboard? B. Since it is single derivative, single s domain, x of s. That's it. And for k, it is k with respect to time s domain. That's it. Okay, that is k of s. K of s. So here, so now you are taking this x, right? Yes. So how it will be in the problem question means mass over here. The mass output is x. It will be like this. And for the dashboard, it will be as x over here. Okay. And for spring, it will be x over. Okay. If the term is x near to the particular component, you will be naming it as x like this. Okay. And for k, it is k only. And what is the output here? X. Then we will be writing it as kx. And if we take the Laplace transform for it is kx of s. Clear? So now, in case of it is a single output. Okay. So I am getting from a dashboard it is single output. If suppose here is the mass here. Okay. In between there is a dashboard, and again here is again a mass over here. So I name it as this is M1, this is M2, and this is B1. Or we will take it as B. Okay. So this mass output is X1. Here the mass output is X2. Okay. So now how you will be writing the differential equation for this thing? We will be writing it as B dashboard. What is the output input X1? Okay. What is the output that is again reaching away from the dashboard? X2. We will be writing this as minus X2. That is X1 minus X2 into B. Okay. So if we take Laplace transform for this, okay, if we take Laplace transform for this, what will be and how will be this? B of X1 of S minus
X2 of S.
X2 of S. That's it. Okay. This is in the same case for spring. Okay. Here is the mass over here, and in center there is a spring. Again a mass over here, and here is the output X1. Here is the output X2. In center there is a spring K and mass M1 and it is mass M2. What is the differential equation for this? K into what is the input for K here?
X1.
X1. What is minus away from the X2 that is?
X2.
X2. Okay. So if we take Laplace transform for this, what will be getting?
K
of
X1
of X minus
X2 of
S. Okay. This is what you want to know for solving the problem initially. This is how you will be taking the values. After that, we will be doing the mathematical production. What we have to calculate? We have to calculate the transfer function. That is x of plus by
f of s.
That is in the system. Initially, we will be giving it as here. Initially, we will be giving it as this as f of s. I have to calculate this f of s. Sorry, I have to calculate transfer function. X1 of s, f of s. What it is? X2 of s by x of s. In overall, the output is x means we will be calculating the
x of s by f of s.
Okay. Initially, you have to see the components, and you want to know the representation of the components and write as equation. Okay. So, as I said, what is the condition to overcome the transfer function? Zero initial condition. So, after writing the equation, you will be writing this as equation. Okay. So, you have to mention that the differential equation for the given system. How will you be writing this? You have to. This thing. If this thing is present in the system is, that is, I am mentioning here, the system is like this. That is for a mass. Okay. Listen. See, if the system is like this, okay. There is a mass here, and there is a dashboard here, and there is a spring here. Okay. This is our x output. And this is f of s. Okay. So this is mass m, and this is dashboard b, and this is spring. For this, I have not know the notations. How you will be writing the differential equation means, see, you have to this for mass. First, you have to consider the mass here. You have to see near to the mass what it is. Near to the what? Dashboard. Okay. So you will be writing the equation as you just know you just want to know. I didn't go to the problem questions. Okay. You will be writing this as m d square x by dt square plus what is the dashpot, that is v dx by dt. Okay, so again, if it is not like this, it is okay, I have to change that. In order to show you the equation for even we have to consider the spring also, right?
Yes,
So
ma'am.
if it is like this, okay. So here to the mass, what it is near to the dashpot is also
Dashpot.
there, spring is also
Spring
there.
is also
So for a mass, dashpot as well as
spring.
spring is also there. We will be writing the equation as like
K.
this. What is the condition? With zero
Initial
condition. So you have to equal to zero. This is the differential equations for the problem.
Yes, ma'am.
That's only this diagram will be present in the question. After seeing this diagram, you have to see how many mass are there. If one mass is there, means mass to the mass what is connected. You have to write it as equation. If one more mass is being connected, means if these two things is given for another, this is mass 1, if this is mass 2. Okay, again here is a dashboard, sorry, here is a dashboard, that is B2. Okay, if this is a system means it will be mentioned like this. The entire thing it will be mentioned like this. Okay,
Yes, ma'am.
so for the, if this is the question means we have to solve accordingly. First we have to consider like the differential equation for mass 1.
Mass 1.
Here to the mass 1 what are the components?
Dashpot.
B and K.
K.
Next you have to consider for,
Mass 2.
you have to take this as equation number 1. And you have to consider mass 2.
2.
For mass 2 what are the components which is connected near to it?
Dashpot.
B,
Spring
K,
K.
and another dashpot
B2.
For that, it will be given as x1, and for this mass 2 it will be given as
X2.
Right? So, for mass 2, if you are considering, if you are writing equation for this B means what? How will you be writing? B into
Bx.
B is connected to M2.
M.
So, B into
M.
x2 minus
X1.
x1. That is B of B differential of x2 minus x1.
Yes.
Clear? Which is nearer, first you have to write.
Yes.
You have to subtract the remaining. I know need of this mass output. So I am writing it as P differential of x2 minus x1. Like for K, how will you be writing it? K into x2 minus x1. And for B2, how will you be writing it? B2
x2 minus
dx2, no x2. See, B2 is only connected to who? M2.
M2.
That won't come x1. Okay, just x1 over here.
Yes.
Just to the mass M1 it goes. So for B2, how will we write it? B2
dx2
is the form single derivation.
Yes.
D of
X.
is output x2
x2
by
by
dt. Yeah.
Yes.
So we have to take this as equation number 2. After that, for 2 differential equation, we will be taking the Laplace transform.
Yes.
Okay, after taking the Laplace transform, we have to bring all the mathematical. If this goes left and right means, likewise we have to do. Finally, we will be calculating the x of us by f of us will be the left hand side, and the remaining all factors will be in the right hand side, and that is our solution. That's how we will be doing the problem that we will see in the next class.